estimation of Central California office, 71% of the Earth's surface is water.
97% of that water is salty water, which is not fresh for consumption, leaving us with 3% of fresh water.
About 2.5% of it is inaccessible.
And it's inaccessible because the water frozen in the ice caps and water trapped underground.
This leaves 0.5% of the water on the Earth's surface to cater for 7.9 billion of the population.
Also, that 7.9 billion, majority live in poverty. Therefore, they are not able to access any of the clean water.
And they are prone to diseases such as typhoid, cholera, E. coli, and bilharzia.
On the other hand, as we all know, plastics are major pollutants of the earth. Therefore, we came up with a way to recycle plastics and purify water for those who can't access it.
Originally, we were going to use dispenser water bottles for our project, but they can't be reused. So we decided to use ketchup bottles and juice bottles used in our school every week for our projects.
Our system entails locally available materials such as sand, pebbles, and charcoal. Let's see how it works.
Welcome to the project Oasis. It is to filter out sediments like leaves and small insects. It is preferable sediments like leaves and small insects. It is preferable to project Oasis. So here at the first stage we have a container filled with water full of pebbles. Here the pebbles function is to filter out large sediments like leaves and small insects. It's advisable to use pebbles since it forms a permeable layers to trap the large particles.
For the second part of the system, it's filled with charcoal, which is highly porous. It absorbs the particles, both inorganic and organic, through the processes of chemical absorption and chemical attraction. It also adds nutrients to the water, like calcium and magnesium.
In the third stage, we have coarse sand and cotton. So the coarse sand is also used to remove some microorganisms that were not released from the pebbles. Yeah, this cotton wool is used for sieving some of the materials as the water passes through. Yeah.
Our project has two major stages, the filtration stage and the purification stage. So for now, we're going to start by demonstrating the filtration stage.
So here we have a sample of dirty water.
We're going to see the water passing through the three first stages. First through the pebbles, then through the charcoal, then through the sand. As you can see, the water is coming out clear and clean, but it might not be safe for drinking. This is a sample of our filtered water, which will go into our purifier. The purifier will use three basic concepts we learned in high school, starting with the Gay-Lussac's law. Yes. So it states that an increase in temperature leads to a corresponding increase in pressure, which raises the temperature again under constant conditions of volume. So this bottle of ours has constant volume, meaning that an increase in temperature from the sun, which will be absorbed by the bottle, will lead to a corresponding increase in pressure inside the bottle. This will lead to another increase in temperature, which will boil the water inside.
So we are to put this bucket on top of this black bottle of ours, where we are going to use the principle of the greenhouse effect. So as solar light rays
come into the bottle, the darker the object usually absorbs the rays and transforms the waves into emitting heat energy. So as the heat energy is emitted, then they are not able to escape back out of the bucket, making it possible for it to retain heat and more heat, increasing the overall temperature that's going to be used in our purification. We're also going to have a reflecting surface, concave, to concentrate the light rays into our purification system, so we can have maximum heat as possible.
Will work hand in hand to boil the water and make it safe for drinking. At our first stage, the water was safe for cooking but not for drinking because it still had microorganisms that needed to be killed by high temperatures. So after it goes through this part of our system, the water will now turn into steam and it will be condensed in our makeshift condenser. It will be collected in our collecting bucket.